Hello, my name is Kushi Kashik, and I'm an incoming graduate student at UCSD. A little bit about my background is that I finished my BScs in computer science and took a bunch of math classes along with it for fun. And I graduated this May 2025. I have been working as a tutor for algorithm engineering, data science, discrete mathematics, and multivariable calculus with machine learning. For the past 2 years, I was appointed by the dean for the tutoring for the entire ECS for the last 2 years. So I've had a bunch of tutoring experience throughout my undergrad journey. And one of the classes I have tutored, which was one of my favorite classes, is compiler design and languages. So this is a trial for TA-ship and token count using lexical analysis in one of my favorite classes, CSE 131. So let's get started. Lexical analysis, so is the very first step in compiler design. We get source code, we do lexical analysis on this to break it down into token. Token is the smallest meaningful unit, like keywords, identifiers, and operators, which is gotten from source code using lexical analysis. So basically what in lexical analysis happens is that we have a code and we break it down into multiple units so that we could analyze it. So how can we break it down and what exactly is the process called? So the process is called tokenization. So this is the exact representation how I would explain lexical analysis. We have the source code. A lot of processes happen in the box. Not a lot, we'll learn about it. And then we get a symbol table for the entries. And there are some steps we need to figure out and focus on in order to understand more about lexical analysis. So lexical analysis does show us all the illegal and malformed numbers in the form of lexical errors. So the first step we need to do is ignore all the white spaces and comments here. We ignore all the comments and the white spaces. They're out. The next step we need to do is categorize in all these keywords. Not keywords, in all these bins, I would say. The third step is detect lexical errors. And then later on, represent in DFA, which we don't have to worry about because it is a later step in the class. So looking here, how we could break it down is we have definitions on the right side. So I know we have done this in OOP, which was in the ancient times. So we could get started with reading all the definitions and then get started with the IO streams, with breaking down the code. So I have broken down the code just for the sake of time. So we have keywords 4, identifiers 5, operators 3, constants 2, string literals, we don't have any, punctuations, and we have 10, and preprocessor tokens, and we have 3. So it is based on the keywords and then all the definitions, and then we could break this down into tokens. And these are all the tokens. And that's it. Thank you.